Hello everyone, today I thought I'd go over one of the problems I encountered on my exam for linear algebra. And for this problem, we need to find values of a, b, and c such that when we put in 0 into the original equation, we get back 5. When we put in 0 into its derivative, we get back 3. And when we put in 0 into its second derivative, we get back -1. Now, since we have 3 unknowns, we're going to need 3 equations, and for that we need to find the derivatives. So first, let's start off by finding the first equation by plugging in 0 and getting back 5. So if we plug in 0 for x, we should end up getting 5. So I'm going to say 5 is equal to, and everywhere we see an x, I'm going to replace it with 0. And now we can simplify this. So e to the 3 times 0 is 0, and e to the 0 is just 1, and a times 1 is a, plus similarly, e to the 0 becomes 1, and c times 0 cancels out c, since 0 times anything is 0. So this is equation 1. Now we need to find the second equation, which is finding the derivative of this. So the derivative is going to be equal to, a is a constant, so we can take that out, multiplied by the derivative of e to the 3x, plus b is a constant, times the derivative of e to the negative x, plus c is also a constant, the derivative of x e to the negative x. And so using the chain rule for e to the 3x, we know we take the derivative of 3x and multiply it times this. So it's going to be 3 e to the 3x. And if we do the chain rule for e to the negative x, it becomes negative. The derivative of negative x is -1, so it becomes negative b e to the negative x. Right, because it's being multiplied by -1. Plus c, and to find the derivative of this, we need to use the product rule, which says we take the derivative of the first, which is 1, multiply it times the second, e to the negative x, plus we leave the second alone and multiply times the derivative of e to the negative x. And similarly to what we did over here, we use a chain rule, and it becomes e to the negative x, but the derivative of negative x is -1, and we multiply all of this, so it becomes negative. And so now this is the first derivative. And from the problem, when we put in 0 into the first derivative, we get back 3. So 3 should be equal to 3a e to the 3 times 0 minus b e to the negative 0 plus c times e to the negative 0 minus 0. And we can simplify this to be 3a minus b plus c, right? Because e to the negative 0 is 1, and 1 minus 0 is 1, and then just becomes c times 1, which is c. So 3 is equal to 3a minus b plus c. This is going to be our second equation. Okay, so that was for the first derivative. Now we're going to find the second derivative. And to find the second derivative, we take the derivative of this. So the second derivative, a is still a constant, times the derivative of, actually 3a is a constant, so 3a times the derivative of e to the 3x minus b is a constant, we multiply it times the derivative of e to the negative x, plus c is a constant still, so we take the derivative of each term inside the brackets. So we take this derivative and subtract it from the other derivative. Okay, and if we use a chain rule here, it becomes 3e to the 3x, and 3 times 3 is 9. So we have 9a e to the 3x. If we do it here as well, it becomes positive b e to the negative x, plus c stays the same since it's a constant, and taking this derivative becomes negative e to the negative x minus this derivative. So we take derivative of the first, which is 1, then we multiply it times the second, which is e to the negative x, and 1 times anything is just, it's that anything, so I'm just going to leave it like that. Plus, we leave the first alone, x, then we take the derivative of the second, which is negative e to the negative x, so it becomes minus. And we can simplify this a little bit. If we distribute this negative, we get negative e to the negative x plus x e to the negative x. And we can add these two, which becomes negative 2e to the negative x. Okay, and now this is the second derivative. Going back to the problem, when we put in 0 into the second derivative, we should get back negative 1. And when we simplify, we get e to the 3 times 0 just becomes 1. Same thing here, plus b. And then we have plus c times negative 2. E to the negative 0 is 1, and 1 times negative 2 is negative 2. And negative 2 times c is just negative 2c. So we have negative 2c. And this is our third equation. So now that we have these three equations, here's the first one, the second one, and the third one, we can put them in a matrix and use that matrix, row reduce it to find the values of a, b, and c. So for the first equation, we have 1a, 1b, 0c, and this gives us back 5. For the second equation, we have 3a's, negative 1b, 1c, and that's 3. And for the third equation, 9a, 1b, negative 2c's, and that gives us negative 1. And this is our a variable, b variable, and c variable. And when we reduce it, we get this matrix. Alright. And from this matrix, we know that value of a is equal to 5/8, b is equal to 35/8, and c is equal to 11/2. And now we found our a, b, and c's such that these conditions hold and the problem is solved. I hope you learned something from this tutorial, and if you see something similar like this on a linear algebra exam or assignment, hopefully you'll have an idea of what to do. And like always, if you have questions or feedback, please leave them in the comments, and thank you for watching.